Hello everyone. This is the first video of video lecture series for mathematics of grade 9. So we're going to start from chapter 5, section 3, which is about sides and angles in a triangle. There are a couple of theorems and examples in this video, which we will cover all of them together. The first theorem goes like this. If two sides of a triangle are not congruent, so in other words, if a triangle has two side lengths that are not equal, then the larger angle is opposite to the longer side. So just read the theorem one more time for yourself and I will explain what that means. Let's say you have a triangle like this. So let's say this is vertex A, this is vertex B, and this one is vertex C. And let's say AB has length of 5 centimeters. And let's say AC is about 10 centimeters and BC is 15 centimeters. So all this, the theorem just tells us this thing. Look at side BC. Okay, side BC is 15 centimeters, right? The angle which is opposite to side BC is angle A here, right? Side AC is 10 centimeters. And the angle which is opposite to this side is B. Okay, since 15 is greater than 10, therefore the angle which is opposite to this side, which is A, is bigger than the angle which is opposite to 10. This is what this theorem tells us. In other words, if you want to order the angles of this triangle, you can easily order them in this way. So first order the sides. AB is the shortest side here. After AB we have AC, and after AC we have BC, which is the longest side. Now the angle which is opposite to AB is angle C. So angle C is the shortest angle in this triangle. That's the shortest one. The angle which is opposite to AC, this side, is B, this angle. So angle B is the next one. And the angle which is opposite to BC, which is this side over here, is angle A. So that angle A is the largest angle in this triangle. Okay, let's see one more example. Order the angles in the following triangle from the smallest to the largest. So you're given a triangle over here and the side lengths are given, and you're going to order the angles of this triangle. So just like before, first we order the sides. Let's order the sides from shortest to the largest. AB is the shortest side. After AB we have BC, and the longest side is AC. Now, which angle is opposite to AB? Angle C, right? So angle C is the shortest angle in this triangle. After C, which angle is opposite to BC? Opposite to BC, we have A over here. So A. And the last one, which is opposite to AC, is angle B. So this is the ordering of the angles of this triangle from the shortest to the largest. Let's see next theorem. This theorem is pretty much just like the first one, but it's kind of opposite, which deals with the sides of the triangle. So in this case, angles are given And now you're going to order the sides of this of a triangle. So let's read it together. If two angles of a triangle are not congruent, again, if they're not the same size, then the longer side is opposite to the larger angle. So let's see how it goes. Let's suppose we have this triangle. Okay, A, B, and C. Let's say angle A is 60. Let's say angle B is 70. And let's say, because they have to add up to 180, angle C has no choice but to be 50. All right. Now, look, angle B is 70, right? And its opposite side is AC. Angle C is 50, and its opposite side is AB. Since 70 is greater than 50, angle AC is longer than side AB. Okay, so this side AC is longer than AB. Okay, more precisely, if you order the angles here, the shortest angle is C. After C, we have angle A. And after angle A, the largest angle is B. Now, the side which is opposite to C is AB. So that's the shortest side. The side which is opposite to A is BC. And the side which is opposite to angle B is AC, which is the longest side in this triangle. Let's see another example. Order the sides in the following triangle from the smallest to the largest. So you're given this triangle, and the angles are given, and we are going to order the sides. So just like previous examples, let's order the angles first. Which angle is the shortest one? It's angle C. After that one, we have angle A. And the largest angle is angle B. Now, okay, now which side is opposite to angle C? Well, it's AB. So AB is the shortest side in this triangle. After AB, which side is opposite to angle A? Well, it's BC. And then finally, what side is opposite to angle B? Which is AC. So AC is the longest side and AB is the shortest one. And this is the ordering of the sides of this triangle. So the last theorem for this video is triangle inequality theorem. So let's read it. The sum of any two-side length of a triangle is greater than the third side. So in other words, if you have a triangle and if you add two sides of this triangle, then the answer is greater than the third side. So for example, let's say you have a triangle like this. A, B, and C. So now if I add the length of AB to the length of BC, the result must be greater than the length of AC. Okay, and that holds for any two sides of the triangle. So if I add AB to AC, the answer is bigger than BC, and if I add AC to BC, the answer must be bigger than AB. And that's the triangle inequality theorem. Let's see one example for this. Is there a triangle with the given side length? So this question has two parts, A and B. Let's see the first part. So you have a triangle, and the side length of this triangle is given by 3, 5, and 7. If I add any two of these numbers, the answer must be bigger than the other one. So we have three cases here. Let's see all of them one by one. So if I add 3 to 5, the answer is 8, which is greater than 7. So this one is checked. What's the other two? Let's add 3 to 7. And this is going to be 10. And 10 is greater than 5. And this one is okay. And the last possibility is 5 plus 7, which is 12. And 12 is certainly bigger than 3. And this one is also checked. So it is possible to have a triangle with these three side lengths. So yes, it's possible. Let's check the second part. Now the side lengths are 4, 6.5, and 11. Let's add them and see if the triangle inequality theorem holds here. So if I add 4 to 6.5, the answer must be greater than 11. So we are going to check this. But 4 plus 6.5 is 10.5. And is 10.5 bigger than 11? Well, no. It means the triangle inequality theorem does not hold for these three numbers. So it's not possible for a triangle to have these three side lengths. So in this case, we say no, it is not possible. And that's it for this video. In the next videos, we will solve a little bit more examples from this section, and then we move on to the other sections of this chapter.